Next one is longitudinal redundancy checking. Longitudinal LRC method for error detection and error correction. In this error detection method, blocks of bits is organized in a table with the rows and columns. We have to earlier discuss with the parity checking VRC or vertical redundancy checking VRC method. In this error detection method, blocks of bits is organized in a table with rows and columns. Then the parity bit for each column. Then the parity bit for each column is calculated, and a new rows of 8 bits and a new rows of 8 bits, which are the priority bits, parity bits for the whole block is created. In this error detection method, a block of bits is organized in a table with rows and columns. Then the parity bit for each column is calculated. New row of 8 bits, which are the parity bits for the whole block is created. This is the another method for error detection and error correction. Error detection method for longitudinal redundancy check. The abbreviation of LRC is longitudinal redundancy check. Longitudinal redundancy check. In this error detection method, blocks of bits is organized in the table rows and columns. This is the sending the parity of bits for the whole block is created. Next slide will be next slide. After that, a new calculated parity of the bits is after that the new calculated parity bits are attached to the original data and sent to the receiver. After that, the new calculated parity bits are attached to the original data and sent to the receiver. The original data will be look like that. Original data transmitting original data transmission to the bits is original data is transmission bit is 1001001. Next bit data is 100111100. The next data was 1011111. Next data is 1110011. This is our original data bit. After that, a new calculated parity bits are attached to the original data and sent to the receiver. Original data is taken as the bits is first. Original data is the 8-bit. Original data bit is 1001001. Then each bit has calculating the 8-bit We have to transmit the 8 bit is first 8 bit 1 2 3 4 5 6 7 8 bit. First we have to collecting the taking the one row single rows all the data will be there. The each 8 bit is divided into column divided into rows and columns. First row first data will be first row, and second 8 bit data is come to the second row, and third data bit is going to be third row, and next data bit going to be a fourth row. The first rows and data bit is first row, second row, and third row and fourth row. First row, second row, and third row and fourth row. This is the data bit is a number of rows and columns. The number of rows and columns is number of rows and columns. The data will be sent, and the data may be sent number of rows and columns. Here 4 rows. So hold how many bits? 1 2 3 4 5 6 7 8 8 8 16 16 bit 16 16 plus 32 bits. Total bits is 32 bit. Total bits is 32 bit. Total data bits is 32. Each total 32 bits that will be taken as the 8 bit. 1 2 3 4 8 bit data. 1 2 3 4 8 bit data. 8 bit data is 1 double 0 1 0 1 0 1 1 double 0 triple 1 double 0 1 0 triple 4 triple 1 0 double 1 triple 1 and double 0 triple 1. The number of rows and number of columns. After that, the new calculated parity bits are attached to the original data sent to the receiver. Original data sent to the original data. That number of rows are 1 2 3 4. Number of rows are 1 2 3 4. Number of columns are taken into 8 columns. First column, second column, third column, fourth column, fifth column, sixth column, seventh and eighth column. Total it will be 8 columns and 4 rows. 4 rows and 8 columns. 4 rows and 8 columns. After that, a new calculated parity bits are attached to the original data and sent to the receiver. Original data may be taken as 1 2 3 4 8 bit 4 rows and 8 columns. Then we have to add it to the LRC bit, longitudinal redundancy check. We have to add it to the longitudinal redundancy check. I have to operate a LSB bit and MSB bit. The LSB bit and MSB bit is taken into total 8 columns and 8 rows. 8 columns. 8 columns are 1 2 3 4 5 6 7 8. 8 columns. We have to operate added to the 2 bits. First two bits and third bit and fourth bit. We have to add it to the exclusive OR operation. When we have to add it to the exclusive OR operation, 1 plus 1 is equal to 0, 0 plus 1 is equal to 1, 1 plus 1 is equal to 0. At LSB bit is the resultant is 0 bit. the resultant bit is 0 bit. Again we have to add it second column. Second column is taken as 1 plus 0 is equal to 1, 1 plus 0 is equal to 1, 1 plus 0 is equal to 1. The resultant of the second bit position is 1, and third column is taken as a 1 plus 1 is equal to 0, 0 plus 0 is equal to 0, 0 plus 0 is equal to 0. The resultant is equal to 0 bit at the third column. We have to take the third column at this bit is 1 1 0 0, third bit column, and fourth row is taken is fourth column, fourth column is taken as to add it as 0 plus 1 is equal to 1, 1 plus 1 is equal to 1 plus 1 is equal to 0, 0 plus 1 is equal to 1. Here fourth bit position will be taken into 1, and fifth bit position will be taken as added to 0 plus 1 is equal to 1, 1 plus 1 is equal to 1, and 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, 1 plus 1 is equal to 0, 0 plus 0 is equal to 0. 0 bit resultant of 0 bit position is the fifth bit position. Fifth bit position will be 0. Next we have sixth row is equal to 1 plus 0 is equal to 1, 1 plus 1 is equal to 0, 0 plus 1 is equal to 1. The resultant will be taken into 1 bit. The resultant will be taken into 1 bit. Then we have to, after that, next position is equal to 7th bit position. Will be consider 7th bit position. We have to consider 1 plus 1 is equal to 1, 1 plus 1 is equal to 7th bit position is equal to 1 plus 1 is equal to 0, 0 plus 0 is equal to 0, and 0 plus 0 is equal to 0. The resultant will be taken into 0 at the position of this 7th bit position. 7th bit position, and 8th bit position is taken into 1 plus 1 is equal to 0, 0 plus is equal to 0, 0 plus 1 is equal to 1. Then we have to consider into the 1 bit. Then overall the resultant bit is considered into a longitudinal redundancy check. LRC is equal to longitudinal redundancy check. LRC is equal to 0 1 0 1 0 1 0 1. That longitudinal redundancy check 0 1 0 1 0 1 0 1. Then original data plus LRC bit, as shown in the diagram, is original data plus LRC bit. Longitudinal bit and LRC bit is considered here. Longitudinal and LRC bit we have to consider 1 0 bit and consider into longitudinal bit. Here longitudinal is the number of rows and number of columns. The original data plus LRC bit 1 1 1 0 0 1 1 1 1 0 1 1 0 1 0 0 and 1 1 0 0 1. Next bit is equal to 1 0 1 0 1 0 0 1. The LRC bit is longitudinal redundancy check. The longitudinal redundancy check bit is added to the LRC bit is 10101010. Next, we have to consider LRC increases LRC bit. LRC bit is increases likelihood of detecting burst error. This method can be implemented by using the burst error longitudinal redundancy check increases the likely for detecting a burst error. An LRC and a longitudinal redundancy check of n bits, we have to consider the n bits can easily detect an LRC of n bits and longitudinal redundancy check of n bits can easily detect the burst error of n bits. Longitudinal redundancy check of n bits can easily detect a burst error of n bits. However, if 2 bits is one data unit are damaged. If 2 bits in one data unit are damaged, if two bits in one data unit are damaged and two bits in exactly the same position, in another data unit are also be damaged. However, if 2 bits in one data unit are damaged and 2 bits in exactly the same position in another data unit are also damaged, the LRC bit is longitudinal redundancy check. A longitudinal redundancy checker will not be detected an error. The burst error, if it is 2 bits in 1 bit position, 2 bit or 1 bit position, and one data units are damaged and 2 bits in exactly the same position in another data units are also damaged, then we have to get the longitudinal redundancy checker will not be detected. Longitudinal redundancy check bit will be taken. Check the longitudinal redundancy check bit. Longitudinal redundancy check bit will be checking to this longitudinal. However, if 2 bits in one data units are damaged, 2 bits in exactly the same position in another data units are damaged, the LRC checker will not be detected. LRC checker will not detect an error. Then we have to consider the next. However, longitudinal redundancy check fail to detect the burst noise. How longitudinal redundancy check fail to detect the burst of noises. Notice that although the 5th bit and 7th bit of if you notice that although the 5th bit and the 7th bit for first bit and second bit data unit have been changed, the 5th bit data and 7th bit data for first and second data unit, first and second data unit, 5th position 7th bit has been changed, but the LRC calculated by receiver LRC calculated by receiver is still the same. the same, still still the same, that fifth bit position and seventh bit position for second and first and second data unit have been changed, but the LRC calculated by receiver is still the same as the LRC is received. Thus, the receiver checker cannot be detected this burst error. And consider here bit to cut into the above example. I have to consider here the data will be error in the bit position 10100011, and then next first unit data is the first, second, third, fourth, fifth bit data is the color will be changed, 0 bit is, and seventh position is 1, and second data unit fifth position is 0 and seventh position is also 1. Then 10100011, and next 00110011, then 1101101, then 1110011. Then LRC bit is longitudinal redundancy check bit is 1010101010, longitudinal redundancy check. Calculating the LRC, calculating for the longitudinal redundancy check for data received. Calculating the longitudinal redundancy check for data is received that changes in the bit position 5th and 7th. Same LRC is calculated by the receiver. Receiver is 10101010. Then compare with the LRC, received bit is 10101010. In this way, some drawback is the same bit position cannot be detected by the longitudinal redundancy check. Then we have to move to the next slide. The main advantages. The main advantages of this longitudinal redundancy check. The main advantages of advantage of longitudinal redundancy check. The internet relay chart is the ability to communicate. That is the main advantages of internet and relay chart is the ability to communicate over the internet in real time. Communicate over the internet in real time. The main advantages of internet relay chart is the ability to communicate over the internet in real time. It allows private channels. Are advantages for educational purpose. It allows the private channels are the advantages for educational settings and class-to-class charts, and also use it for the teaching by the lecture in class by class or class-to-class class chart, since the channel won't shows on the channel list. And the outsider channel list and outsiders won't be able to send off topic messages, send off topic messages. These all are the main advantages of The main advantages of redundancy longitudinal redundancy checking method. This is the longitudinal redundancy check method. The main advantages of internet relay. The main advantages of internet relay chart is the ability to communicate over the internet in relay time. It allows private channels. It relates to private channels. Private channels are advantages for educational purpose. Settings and class to class charts. Since the channel won't be shown on the channel list, the outsiders won't not be able to send off topics. And this is the way we have to send this main advantages of this longitudinal redundancy check. Then we have to go to the next slides. I can take the many examples. We have to take the many examples. Many examples for number of rows. You have 32 bits. You can take about 1000 bits, 100 bits. You can take also 1000 bits, 2000 bits. Each bit converted into rows and columns according to the examples of the block diagram. According to the block diagrams. According to the block diagrams as shown here, here only consider as 32 bits. 1 2 3 4. You can 32 bit or can consider 1000 bits and 2000 bits and number of 8 bits, 8 bit and number of rows and number of columns. You can divide the number of rows and columns for another example to find out. But same data unit, same bit position of more than 2 bits, it cannot be detected. This cannot be detected. This cannot be detected. Then we have to main advantages, and the next we have to discuss the then data transmission. Here there are two methods used for the transmission. The transmission between the digital transmission between the digital devices, that is serial transmission and parallel transmission. That will be serial transmission and parallel transmission. Serial data transmission send the data bits one after another over a single channel. Serially data transmission sends data bits one after another over a single channel. Serially data transmission sends the data bits one after another over a single channel. Parallel data transmission sends multiple data bits at the same time over multiple channels. Parallel data transmission sent to the multiple data bits at the same time over multiple channels. Multiple channels, the data can be transmitted parallelly one by one. At a time whole data will be transmitted. Then multiple of data. Defined data transmissions. When we enter data into computer via keyboard, and each keyboard element is encoded by the electronics within the keyboard. The data transmission when we enter data into the computer via keyboard, and each key element is encoded. Each key enter into different characters or different elements that will be converted into encoded bits by the electronics devices to transfer the information within the keyboard into an equivalent binary coded pattern and into an equivalent binary coded pattern using one of the standard coding scheme. Coding the in digitally, the signal will be transmitted in the form of using one of the standard coding scheme that are used to that are used to keyboard into equivalent binary coded pattern using one of the standard coding scheme that are used for the interchanging of information via interchanging from one data into one computer to another computer to share the information. To represents all characters of the keyboard. To represents all characters of the keyboard and unique pattern of 7 bits or 8 bits in size is used to prevent all characters of the keyboard and unique pattern of the 7 bits or 8 bits unique pattern of standard coding scheme that are used for the interchanging of information to prevent represents all characters on the keyboard unique pattern of 7 or 8 bit in size is used to prevent all characters of the keyboard all the characters of the keyboard use the uses of 7 bit means that 128 in different elements. The use of 7 bits means that 128 different elements can be represented, while 8 bit can be represents 2 to the power of 8 is equal to 256 elements. To represents all characters of keyboard unique pattern of 8 or 7 or 8 bits in size is used. The uses of 8 bit means that the uses of 8 bit means that 128 different elements can be represented, while 8 bits can be represented to 256 elements. A similar procedure is followed at the receiver that decodes every received binary decodes every received binary binary pattern into the corresponding characters. Second binary, a similar procedure is followed at the receiver that decodes every received binary pattern into the corresponding characters. To represent all characters of keyboard, unique pattern may be 7-bit or 8 bits in size is used. A similar procedure is followed at the receiver that decodes every received binary pattern into the corresponding characters. Corresponding characters. Corresponding characters we have to send to the each characters. We are transmitting the data bits into characters. This is the way we are to transmission the bit is to use the 7 bits means that 128 different elements can be represented 8-bit. Main advantages we have to follow this. Basically this longitudinal redundancy check is detecting the errors. Longitudinal redundancy check. This is in this chapter, in this topic, error detection method. This is longitudinal redundancy check is the error detection method. A block of bits is organized in the tabular form. It can be converted into a tabular form table with rows and columns. Organized in a table with rows and columns. Then the parity bit for each column is calculated and new row of 8 bits, which are the parity bits for the whole block is created. Whole block is created. And after that a new calculated parity bits are attached to the original data. That will be original data is we consider as original data is 32 bit divided into 8 bits. The 8 bits converted into rows and columns. 8-bit rows and columns. Here the 32 bits only 4 columns are needed and 8 columns, 4 rows and 8 columns. Then after that we are transmitting through a cable. That bit of data 1, 2, 3, 4. The transmission of data 1, 2, 3, 4. The transmission of binary data 1, 2, 3, 4 plus added to the original data and the original data plus LRC, longitudinal redundancy check. Longitudinal redundancy check, original data plus longitudinal redundancy check bit. This is the way we have to transmitting the checking the longitudinal redundancy check. Then after that LRC increased longitudinal redundancy check bits are increases the likelihood for detecting burst error and longitudinal redundancy check LRC of n bits can easily detect burst error of n bits. However, if two bits in one data unit are damaged, if two bits in one data units are damaged and two bits in exactly the same position in another data unit are also damaged, the LRC checker will not be detected an error.